Hello students. Uh, so today in this online class what we are going to discuss is the continuation of the topic what we have discussed in the previous one. That means we have discussed something regarding the ray optics. In that, ray diagrams of lenses we have discussed. So of course in the previous class we have discussed about lens, what is lens, definition, and its sum of the parts. That means how to define a lens, all those things we have discussed. And next what we have discussed apart from that one is like how to understand lens, how many types are there, all those things we discussed. And then what we have done at the end is we have to draw the ray diagrams in order to understand how the image formation will take place in a given lens. So we have done all those ray diagrams, and then around 5 ray diagrams regarding the convex lens, biconvex lens we have discussed, right? Now today what we do is one more lens is there, and that lens won't be having different variations in the formation of images. It always forms a kind of image at one particular place. Okay, so let us discuss about that and then we'll continue. Okay, one of the derivation is there today, very important derivations, and let us discuss first about the concave lens. So I will write on here continuation, image formation in concave lens, image formation in concave lens. So first concave lens, biconcave lens I will take like this, and then neatly you have to draw along with the scale and proper pencil or pen, whatever, but the alignment and the geometrical shapes of the image should be proper. Okay, hope you people are maintaining a separate and clean notes for the board syllabus what we are discussing online class. Everything should be taken down neatly in your notes. Next, of course, optic center, the point where image appears to be diverging, that is called principal focus in case of concave lens. Convex means point where the parallel ray of light converges. And 2f I will take twice that of this, that is 2f, 2 times that of focal length, and here 2f. Wherever you keep, you can keep the object wherever you want. Okay, here, that means beyond 2f or in between 2f and f, or in between exactly on f or 2f, or in between optic center and principal focus. What you're going to get is, let us see now, object. Right now I'll be taking the position of the object in between f and f. Okay, next, one ray of light has to pass parallel to what? Parallel to the principal axis. So I'll use some other color chalk. Yes, so ray of light is incident here. So let me take a reference point like this, okay, from where refraction is taking place. You know that a parallel ray of light has to do what? Undergo what? Yeah. It undergoes fraction. And one more light, what happens? It has to pass undeviated, because it is thin lens, right? So undeviated it has to pass like this. 2 ray of light I have taken. Now right now these 2 rays of light, they are diverging. So in case of diverging, whether it is possible to have image formation, answer is no. So now what is the remaining thing to us? That means we will be extending that one in the reverse. That means it appears to be diverging from one particular point, right? So what is that point? We will retrace back that. So while retracing back like this, while retracing back, it will be is diverging from a point called principal focus. So this is where the image has formed. Now you can see here image has formed like this. You can give name, tail as head of the object, A and B, all those things you can do. But here, yes, you can see image, dotted image, okay, like this. So in case of concave lens, wherever the position of the object in between or any two or beyond whatever, we have to get a diminished erect virtual image. In all cases we have to get what? Diminished virtual erect image. In case of what? In case of a concave lens. So hope it is clear. So we are having an image formation in concave lens, and whatever the position you take, position of the object when it is placed in front of the lens, beyond 2f or in between f and 2f, or in between f and o, or on f, on to f, wherever you want, always you are supposed to get what? One and only kind of image, that is a diminished erect virtual image. That is what the image formation in case of concave lens. So right now, regarding lens also we have discussed. Regarding the sense convex lens, right now it is concave lens. So now what we do? We go for the further. So now, before going to start with the concept, you might be knowing, soon after studying about the image formations in case of mirrors, what we have done is, we have discussed regarding the derivation called mirror formula, right? So whereas in mirror formula, you know the formula is 1 by u plus 1 by v equal to 1 by f. Like that, is there any formula which are there for like lens formula, whether it is possible? Answer is yes. But we are not going to do any derivations here because it is not included in the syllabus for you people. So what we do is, we learn the formula, but there is no derivations in case of lens formula. So we just discussed that, yes, what is the lens formula and what is the linear magnifications formula here. Everything is one and the same here, but sign convention slightly different. So let us study about that. So next, that is mirror, sorry, not mirror. We are discussing about lens. So lens formula. No derivation, whereas 5 mark derivation was there for mirrors. So lens formula says minus 1 by u, you have to take down very important formula it is, for numerical purpose as well as for competitive examination purpose. This formula is very important. Minus 1 by u plus 1 by v is equal to 1 by f. So this is the formula, that is lens formula. Okay. So what is lens formula? 1 minus 1 by u plus 1 by v equal to 1 by f. Next, soon after studying about mirror formula in the mirror concept, then we have studied about what is linear magnification and what are the different formulas. So here also the same thing is there. So you might be remembering what is linear magnification. Let us discuss. Linear magnification. That means in case of image formation, there may be a enlarged image or diminished image. How much enlarged? That means it has become bigger. How much smaller? All those things we can discuss. No, that is what here. Okay, linear magnification. What is the formula for? General formula we know. In case of mirror, it is ratio of height of the image divided by height of the object. Here also same. Here also same. Linear magnification equal to height of the image by height of the object. And there we know minus v by u was there in case of mirror, whereas here there is no minus v by u. This is just v by u. And similarly, some other small derivations I have done there in order to get some other kind of formation of the what is that formula. So here this is f minus v by f. Also, you might be remembering, okay, just go through this. So one more formula is there, that is f by f plus You know how to get all this because I have shown you some small step derivations in the previous concept called mirror. Here also you can apply, and with the proper sign conventions you will be getting this formula. So this one of linear magnification means what? It is a ratio of height of the image to height of the object. Proper definition should be written, okay, along with explanation. Then also you can ratio of image distance to object distance, like that also you can explain. So that is all about lens in that image formation in case of which one? In case of a concave lens. Then we discussed about what? In case of, yes, like similarly like in mirror formula, all those things we have discussed in the mirror concept. Here also we have got lens formula, and this is about lens formula, right? And then it is linear magnification concept, where we have discussed in mirror concept itself. Here also it is same, but small variations are there in the substitutions. Slight different formula we get. Very important formulas, write down neatly. Done. Next. So next is about one of the very important 5-mark derivation, and the derivation is something regarding manufacturing of lens. Okay, so manufacturing of lens means, you know, a lens, what and all the applications of lens are there, because you know that optical instruments, camera, video cameras, okay, telescopes, thereafter many more, microscopes, all these instruments are highly precise, highly they have got so much of vast, what is that called, applications, and they are very much advanced right now in different fields, correct? That is why all these kind of instruments has become more and more advanced because of advancement in the case of what? In the geometric optics. So concept of geometric optics in the sense mathematical application in case of formation of image, all those things using optical medium such as glass, lens, mirrors, etc. Correct? Even also what is that? Prism. So all these are there, right? Suppose imagine that you are having some eyesight problem. So when you go to the doctor, so they will be checking your, okay, the formation of image, where exactly it is forming on the retina, all those things. So they will just make you, they will get the informations about your eye. Then they will get your spectacles. So when you wear that, it will be properly visible, whatever you may be having a short-sightedness or long-sightedness. So how they will decide? So do you think that for everyone they have kept a proper spectacles will be there? When you go, they will pick one spectacle and give you? Not like that. So they have to manufacture that according to your eyesight problem. So how they are going to manufacture that? They will be manufacturing that along with the concept something called lens maker's formula. Okay, one of the very important 5-mark derivations. So before that, there's a small correction is there. Maybe you remember we have discussed about some shifts like normal shift, lateral shifts, all those things. Whereas I have come across a lateral shift formula, that is lateral shift LS is equal to T into sine I minus R divided by sine R I have written, correct? So actually ratio, right? Ratio of, so made a small mistake there, so make a correction, is cos R, okay? So make a change, that is lateral shift is equal to T into sine I minus R divided by cos R, whereas normal shift equal to what? Normal shift is what? Normal shift actually the ratio of real depth by apparent depth. So this is a formula, make a note, LS equal to lateral shift equal to thickness into sine I minus R divided by cos R. Make a change in your notes. Fine then. So now what we do is we go for the derivation. One of the very important derivation for how many marks? It is 5 marks. So let us get to the derivation. So derivation is how to understand this. Derive the lens maker's formula. Okay. The name or the derivation will be like derive the lens maker's formula, or derive the relation between focal length and radius of curvature and refractive index of a lens. Like that also the question can be asked. Okay, remember that. So let us go for the lens maker's formula. So lens maker's formula, whether it's a scientist name? No. That means how they will manufacture lens, that is it. Lens maker's formula. Very important. 5 marks. Okay. Yes. Very, very important 5 marks derivation. That is lens maker's formula. So how to understand lens maker formula? I told you people regarding the optical instruments, how they are advanced, how they are very much useful. All these depend upon what? Lens. Without lens they are useless. So whatever, they may be 10 lakh, 20 lakh, or that much of expensive. All those expensive, why? Because it's actually because of the lens. You might be knowing in National Geographic Channel, Discovery Channels, the photography has got videography, photography there, wild animals, all those things are there, right? So it has got that much of what is that need nowadays. And suppose they are capturing any animals, that means wild animals, they don't go very nearby, they will be sitting at a faraway place, they will be zooming that. To do that they require lenses, telescopic lenses. So the rate will vary from lakhs to 10 lakh, 20 lakh, 30 lakh, something like that. So that much costly camera there. Do you think that it's all because of the electronics components which are there inside the camera? Not like that. It's all because of the lens and the telescopic concept of lens there. So that is a device which is most costlier, because you have to get the clear, crystal clear kind of image where the lens has to be that much, quality, correct? Yeah. So now let us discuss about lens maker's formula. So lens maker's formula means what? Lens maker's formula means it's a formula which will give the idea of how to manufacture the lens of a given focal length. So by this we can understand what is the concept, in the sense what is the benefit of learning the lens maker's formula. We can design lens of desired focal length, and we can use that for different applications. Okay, so first what we do is we will be doing the diagram. So diagram is like this. So one of the diagram, simple diagram, it is like a ray diagram. Let us take down that. Diagram is very, very important. So neat diagram you have to draw. So principal axis. Okay. Next, a lens. Okay, it has gone slightly like this. It's okay. Fine. Or suppose you want more clear kind of image, means you can just make it, it's a thin lens, you can make it thick, because for the purpose of derivation, right? Yes, you can make it slightly thicker also, no problem, because if I use thin lens in diagram you won't be able to see that clearly. Okay, whatever, I have made slightly a thicker lens, but in your notes you no need of doing very thick lens, okay, because the concept is actually based regarding the thin lens. So I have taken a lens like this, biconvex lens. This is optic center, but optic center I don't mention here, okay, because in the entire derivation we will be following the refracting surface concept. You might be remembering 5 mark very important derivation. In the previous derivation we have done about refracting surface, spherical refracting surface, where pole is there, right? So here also optic center it is, there is no pole, but we will be using this one as something like it is actually made up of two spherical refracting surface. That concept is there. That is why I am not going to mention it as optic center. We know it is optic center, but still we are going to assume like that. Okay. Now what I do is, one point I will take. So here, to understand this more clearly, what I do is, look at here, I will draw like this. This lens can be understood like this also, right? It is made up of two spherical refracting surface like this, correct? This is also first refracting surface, this is second refracting surface. two refracting surfaces are there like this, correct? So now these two refracting surfaces can be assumed by using the lens. This lens can be assumed like this, two refracting surfaces facing each other getting intersected, where it will form like this kind of, if you cut that one, that looks like what? It's a lens. So next what I do, next I will take the, I don't take any object like a arrow mark, all these things. I will take, in case of refracting surface, you might be remembering, a point will be taken place, will be placing, image will be formed, image space will be there, object space will be there. So like that I will take a object. So instead of writing A, B, all those things, I will just take object as O. I am not considering this one as optic center here. Why? Because you understood, I am considering this lens as what? Intersection of two refracting surfaces. Okay. Next, a point, luminous point is there. Where? In the object space. So this I will take refractive index N1. This I will take, it has got refractive index N2. So a lens of proper focal length F is surrounded by refractive index N1 and ray of light. Okay. So I will take the ray of light. First ray of light I will take here. A ray of light falling on surface like this. We know once a ray of light enters on a refracting surface, it undergoes what? Refraction, correct? So it has to refract like this. Yes, it is refracting. O incident. Okay, I will take this one as P. Ray of light OP incident on which one? The first phase of which one? First phase of the lens, biconvex lens. I will take this one as A, B, C, D. So right now a ray of light OP incident on phase which one? A, B, C. First phase undergoes refraction like this and emerges out as, again it has to undergo what? Refraction, am I right? Because this is denser to rarer. Again refraction takes place like this. And now one more thing I will consider is, if it was not undergoing refraction means, what would have happened? This ray of light would have continued like this straight, okay? That means if it was not having this surface, this ray of light would have continued like that. Okay, somewhere here it will form image I dash, here I will take like this. If in the absence of ADC, this light ray will bend once, that means it's a hole. You can see this is the refracting surface, right? The ray of light will just go like this till here. Because of the presence of ADC, again it has to bend, because of again refraction takes place, because denser to rarer now. So this is also N1. So this I will take V, okay, and this I will take V dash. I will tell you why we are taking like this. This is object distance U. Like this properly you have to take the diagram, okay. Then let us continue. So I hope the diagram is clear for you people. You can have a look and what and all things we have mentioned there, okay. So this diagram you can see where the object is placed. Object in the sense a luminous point is there on the axis. Which axis? That is the principal axis. So now I will just mention like this. Why? Because a ray of light is there which passes through the which one? Through the principal axis undivided, because you know minimum how many rays are required to form the image? Yes, of course, that is 2, right? So that is why I'll just take like this. Okay, rough diagram. Like this way it goes. Done? Okay, fine. So what and all things are there? First you have to write down, consider a thin convex lens of focal length f, refractive index of n2 surrounded by a refractive index of n1. Next, here you can see two phases are there, right? This I will take that means radius of curvature r1, radius of curvature r2. For which phase? For phase ABC. If you continue, this becomes a refracting surface, right? Let us take R1. For phase ADC, like this, you can see there, I will take radius of curvature as R2. So here I have mentioned everything, like how the concept we are going to take here. Next, what we have to? We have to mention what is the formula for a spherical refracting surface. And you might be remembering, spherical refracting surface is given by, what is the formula? Minus N1 by U plus N2 by V is equal to N2 minus N1 divided by R. Correct? How to write this? You have to write in words, okay? How to write in words? Minus refractive index of object space divided by object distance plus refractive index of image space divided by image distance, correct, is equal to, again, refractive index of, what is N2? N2 means image space, refractive index of image space minus refractive index of object space divided by, what is this? R means radius of curvature. So like this you have to write down, okay? First step, what is that? First we have to, yes, consider a lens, biconvex lens, has got focal length f, has got the what? Yes, refractive index of n2 surrounded by refractive index of n1. Next, you can see a ray of light OP incident on face, which one? A, B, C. Like that you have to write, okay, step by step. Undergoes refraction PQ. Then again undergoes refraction for the face ADC, and that is why forms the image at I. According to what? What we are assuming here? We are assuming this biconvex lens as intersection of two, yes, spherical refracting surfaces. So ABC, this spherical refracting surface has got radius R1. This has got what? R2. So that is why we are using the concept of that derivation we have done. So minus N1 by U plus divided by U, N2 by V equal to N2 minus N1 by R. And we have to write down that, okay? It's very important. If you write down like this, then only the marks will be counted, because we are explaining that in terms of this, correct? So this is what we have mentioned now. Now what I have to do is I have to split this, in the sense I am taking this derivation in two parts. What is that? First part is refraction at surface ABC. That means first spherical refracting surface, then next one. So two cases, okay? So I am going to do this in two steps in this derivation. Step 1. So what is step 1? Step 1 we have to write refraction at surface ABC, okay? So refraction at surface ABC, you can see, I will just show the diagram, okay? How does it looks? It looks like this, correct? A spherical refracting surface. This is A, this is B, this is C, this is object. Sorry, only one time refraction takes place. And it forms image. Whether it forms image at I? No, because it is because of this one. Now it has to forward straight like this, correct? Because there is no second phase, only one phase. So it goes like this, it has to travel till here. That means which one is the image formation now? Yeah, I dash. So V dash becomes what? Image distance. This becomes what? object distance. Hope it is clear for you people. Understanding, right? So now, at face ABC, step 1, refraction at surface ABC. No need of drawing this one in examination. You can just, okay, just for reference I have taken now, okay. Now, what I am doing, applying the formula. Which formula? Applying the spherical refracting surface formula. This formula, it's a general formula, right? This is a general formula. I am applying this one in this case. Which case? This case. So, what is a, here it is N2, right? So, this one is minus N1 by U, correct? Plus N2 by V, but V dash here, correct? Is equal to N2 minus N1 by, what is the radius of curvature of this face? R1, correct? So, I will take this one as equation number 1. Then I will take this one as equation number 2. So, have a close look now. What I have done is, I have taken, which one? I have taken diagram and I have applied spherical refracting surface derivation, what we have done already. Then I have written that in words. Then what I have done, I told you people I am going to do this derivation in 2 parts by considering this lens is actually because of the 2 spherical refracting surfaces. First I have went for ABC. So first step 1, refraction at the surface ABC, and I have shown you people which one is image space. This one is image space. This is object space. Object distance, image distance. Refractive index R1. So that is how the second equation is slightly different from first equation. So next, I think it is clear for you people. Okay, I will continue here itself. I'll erase this. Hope you have taken down already. Next step is step 2. I will continue here. Step 2. Refraction at surface ADC. ADC. What is the refractive index of ADC? Sorry, radius of curvature ADC. That means R2 is the radius of curvature, correct? So, what you have to write? Refraction at surface ADC. Then you have to apply what? Applying the formula of spherical refracting surface. What is that? Refractive index of object space. So, first I will draw the diagram. This looks like this. But where is the object now? This is N1. This is N2, correct? But whether object is there, if you forget about this one now, object is not there. Why? Because this object, the light has bent like this only because of this surface. If this surface was not there, means this ray of light is not possible. So this will look like I here and I dash here. This ray of light coming like this, somewhere like this. So whether it is possible to have a ray of light from infinity? No. So now what we have to assume here, we have to be very careful in this case. In this case, what you do? No. Here, because of luminous point, because of ABC, ray of light is bent like in this direction. That is why this image is formed. Now, ABC is not there to bend like this. That means this ray of light is having no meaning. That means it looks like what coming from infinity for the face ADC. So, I have made a dotted line. So, from infinity it is coming. So, what we have to assume? I will take this one as image distance, correct? Then, this one as the virtual object. Which one is virtual object? I dash. You can see I dash is the virtual object here. The ray of light. Like this it is. No. It looks like this. So virtual object means I will do what? I will just take yellow dotted line on this. Okay. Virtual object it is. Which one? I dash. Because this light here at I image is forming, but the layer of light is looking like what? Coming from infinity. So I will take this one as what? Virtual object. Which one is virtual object? I dash is virtual object. So object distance is v dash, image distance is v. So now what I have to apply? Apply what? The formula. Next is equal to refractive index of object space. Where is object space here? Object space is here. That means object is here, but light ray is coming from which one? Object space. So which one is object space here? This one is object space. So minus n2 by object distance. What is that object distance? V dash. Hope virtual, no, that is why. Don't think that okay, coming from here, no, that means some measurement should be done taken inside, right? No, it is virtual image, virtual object I dash looking like coming from infinity. So object distance in the sense, object space means what? From where it is coming? Yes. So n2 by v dash plus n1 by image space. Yes, image is forming here. So it is image. Next, what is that? Next formula, continuing, what is that? That is mine is equal to, what we have to write? Yes, that is refractive index of image space. So what is image space here? n1 minus n2 by, what is the radius of curvature? r2. I will take equation number 3. Carefully have a look on the diagram. Like that you have to take it. Okay. Next what I do? I will continue. So equation number 3, equation number 2 you can see now. So I will continue here. I will erase this. Hope the diagrams in both steps is clear for you people. You can watch the videos twice. It will be useful for you. So from the start you have a look. You can make it easier. Okay. Next, continuing, I can write this equation. Which one? Equation number 3. Slightly in different way. What is it? Minus n2 by v dash plus n1 by v is equal to minus n2 minus n1 divided by r2, correct? Or I will take this one as equation number 3, okay? So now you can see equation number 1 in your book, equation number 2, equation number 3. All have got some similarities. So now what I do is, because of substitutions I require adding. Simple derivation it is. Adding equation 2 and equation 3. So while adding those two, what I guess? Equation number 1. Equation number 1, yes, you remember that, correct? So equation number 1 and equation number 2. Soon after adding, what we have to get is, I'll directly write down that. Do the substitution in your book. So we will get n1 into minus 1 by u plus 1 by v in the left hand side of the equation. Right at the side of the equation, what do you get? n2 minus n1. So common. Then into 1 by r1 minus 1 by r2. Hope you can see that. Next, I will write down this like this. Minus 1 by u plus 1 by v equal to n2 minus n1 divided by n1 into 1 by r1 minus 1 by r2. Adding these two equation 2 and equation 3, I got like this. Then I am doing some substitutions. And now you can see this equation. What is it? Minus 1 by u plus 1 by v. You have seen that equation. What is that? Yes, Lenz's formula. Lenz's formula we know. Since Lenz's formula is 1 by f equal to 1 by minus 1 by u plus 1 by v. What we can write? We can write f equal to, what is that? F equal to this one, correct? So f equal to n2 minus n1 divided by n1 1 by r1 minus 1 by r2, like this. So this is the very important 5-mark derivation. Okay, carefully have a look. So while explaining this, how I have explained, like that only you take down, so that it becomes a proper notes. So I just repeat once again. What we have taken here is, we have taken a derivation for 5 marks, very important. that is lens maker's formula. What is lens maker's formula? Definition you have to write. Okay, definition, what is that? The formula which helps in manufacturing of lens of desired focal length. That is a definition. Then diagram. We are taking a lens, thin lens it is, but it looks like thick lens because diagram point of view I am drawing like this. And you know how many faces are there? Two faces, ABC, ADC. We assume this one as intersection of two spherical refracting surface having radius of curvature R1 and R2. For that, what we have to do? First, applying what? Spherical refracting surface formula. We have taken that minus n1 by u plus n1 by n2 by v equal to n2 minus n1 by r. First, then we have written that in words. Then we started with, we have made this derivation in two parts. Step 1, step 2. Step 1 for which one? ABC surface, considering this one as a whole spherical refracting surface. Step 2 is what? Considering ADC surface, considering this one as a whole, what is that? Spherical refracting surface. And then what we have considered? For second one, I told you, I dash is a virtual object because this ray of light is actually because of bending due to the ABC surface. Where ABC surface is absent, so this ray of light looks like what? Coming from the infinity. That is why you have taken V dash as the virtual object. So object distance is V dash. Here this one is V. So carefully have a look in the derivation. So equation number 3 is minus n2 by, sorry, equation number 2 you can see. Equation number 2 is what? Equation number 2 is, that is minus n1 by u plus n2 by v dash equal to into minus n1 by r1. Equation number 3 is minus n2 by v dash plus n1 by v is equal to minus n2 minus n1 by r2. By equating, in the sense, by adding those two equations, what we get? We are going to get what? Yes, we will be getting minus 1 by u plus 1 by v is equal to n2 minus n1 by n1 into 1 by r1 minus 1 by r2. And as we know, according to the lens formula, 1 by f equal to minus 1 by u plus 1 by v. So hence, this will be the formula, focal length, f equal to what? N2 minus n1 by n1 into, what is that? Yeah, 1 by r1 minus 1 by r2. So finally, at last, after writing this, you know that, here, lens formula 1 by f equal to, right? 1 by f. Okay, fine. So we know that, what is power of lens? Ability of the lens to converge or diverge. Since power of lens 1 by f, this formula we know, you can see there. Right now, what is the derivation we have got? So derivation what we got is, yes, correct. So now what we can write? Therefore, P is equal to 1 by f is equal to n2 minus n1 divided by n1, 1 by r1 minus 1 by r2. So this is the lens maker's formula. Very, very important. 5 marks derivation. Okay. So it is in case of two medium. Imagine we have taken air as the surrounding medium. In that case, the formula can be written quite shortly. What is that? Because n1 you know it is equal to 1. So P is equal to 1 by f equal to n minus 1 into 1 by r1 minus 1 by r2. This formula when we have to use in case of vacuum or air. So this is all about the lens maker's formula. And take down the derivations properly and write it cleanly. Ray diagram should be made very proper. So write down the derivations and thereafter note down that one in your notes. So study well. That is it. Thank you.